Good morning, everyone. This video is to go through your 10-2 notes with you. This is about finding arc measures, and this is our second lesson in chapter 10. So just a reminder, we will have a quiz next Wednesday. Next Wednesday is April 16th on 10-1 through 10-4. So just the first 4 lessons. So the first part of this is just vocabulary. It's about central angles and arc measures. So a central angle is an angle with its vertex at the center of the circle and its 2 sides are radii. So its vertex is at the center of the circle and its 2 sides are radii. Remember, when we're talking about more than one radius, we don't say radiuses, we say radii. So this is a central angle. Its vertex is on the center of the circle, and its 2 sides are radii. So for example, this angle that I have to call, or I'm going to call angle ABC, is a central angle in circle B to the left. The sum of all central angles in a circle, if you think about all the way around the circle, it's 360 degrees. So every central angle is going to form an arc. Well, really more than one arc. So the measure of the arc formed by the endpoints of a central angle is equal to the central angle. Equal to the central angle. And we'll talk about that a little bit more as this lesson goes on. This next part will be described a little bit more below, but I'll just kind of briefly explain it here. This means the measure of arc AC is how I would read that out loud. This is arc AC. You're just connecting A and C on the circle. It's not necessarily the length of it, it's just the degree measure of it. So the measure of the arc is equal to the central angle. So it's created by an 84-degree angle, so this is 84 degrees. This next part that I'm highlighting in orange, the measure of arc ADC, means a different arc. That means I'm supposed to start at point A on the circle, which I'm doing, and I'm traveling around to D and then to C, so it's this orange arc. So that arc would have to use the idea that all the way around the circle is 360, so it'd be 360 minus 84, which is 276 degrees. So this next little box right here is just kind of explaining different types of arcs. We did already talk about this a little bit in terms of the notation up here. But a minor arc up here, this would be a minor arc. It's less than 180 degrees. You only need 2 letters to name it. So a minor arc, I'll just pick 2 points on the circle. The minor arc, if this is A and this is B, this would be the corresponding minor arc. I could call that AB or I could call it BA. It doesn't matter. And you just put a little like arc over it, meaning you're talking about the outside of the circle. A major arc is more than 180 degrees. You need 3 letters to name it. Because if you think about it, if I'm talking about this point A, or I'll call this C and I'll call this D. If I just say CD or DC, it's implied that I'm talking about the minor arc. If I want to talk about the major arc, as in going like all the way around this way, I need to name a point that's in between those along that path. It doesn't need to be in the middle of them, but I'll call this point F. So then I would call that major arc, the one that I have highlighted in orange, I could call it CFD, or I could call it DFC. A semicircle is always exactly 180 degrees. You do need 3 letters to name it. So you just want to pick 2 points that are 180 degrees away from each other. So I'm going to call this J, and I'll call this K. So if I'm talking about this top major arc that I'm going to highlight in blue, I can't just say JK because a person like reading that wouldn't know if I meant the top one or the bottom one. So to talk about that major arc, you need another point on it. So I'll put another point over here. Then I would call that blue semicircle JLK. Or I could call it KLJ with an arc on top of it. Make sure you're putting an arc on top of it like a curve instead of a straight line. So down here, we're just kind of using the ideas from this page. So it says find the measure of each arc. Remember, a measure of an arc is a degree measure. It's not an actual distance. of each arc of circle P, where RT is a diameter. So they tell you that RT is a diameter. RS, so if I'm highlighting RS, the minor arc, because it's only 2 letters, from R to S is this arc right here. It's equal to the central angle, so that arc would be 110 degrees. So this is 110 degrees. The next one is RTS. So this one, RTS, I'm going to travel from R to T to S. I need that orange arc. We're going to have to use the fact that the whole circle is 360 degrees. So it'd be 360 minus 110, which is 250 degrees. And then the final one on here is arc RST. So go from R to S to T. So it's the yellow arc on my diagram. That's a semicircle because they tell you RT is a diameter. So it's exactly 180 degrees because it's half of the circle. So that first page was mostly just about kind of just notation, vocabulary, and then the idea that the central angle creates a congruent like arc in terms of the measure. This next page, we have something called the arc addition postulate. So remember, if it's a postulate, it kind of usually means that it's something that you might be able to figure out even if we didn't tell you this. But it says the measure of an arc formed by 2 adjacent arcs is the sum of the measures of the 2 arcs. So honestly, you probably could do this next example without even knowing that arc addition postulate. So here it's telling you like the arc ABC, and mine's color coded, or you can actually see the colors on my screen, but if you go from A to B to C, so major arc ABC, it's equal to the red arc on my picture plus the blue arc. So hopefully pretty like logical. So down here, we're kind of using that, or just, so this is GE. So arc, it says find the measure of each arc on this example. So arc GE is right here. It looks like it's created by a 40 and a 80 degree central angle. So you just have to add those together. So this would be 40 plus 80, which is 120 degrees. The next one is arc GEF. So arc GEF from G to E to F. I'm going to highlight that in blue. From G to E to F. It's a major arc. It's more than 180 degrees. So here I see that I have 40 plus 80 plus 110 create that. So 40 plus 80 plus 110 is going to be 230 degrees. The next one is GF. So GF, arc GF, I will highlight that in orange. Arc GF would just be 360 minus the blue one. And I just found the blue one is 230 in part B. So it'd be 360 minus 230, which is 130 degrees. There's a couple U tries here. So it says find the measure of each arc of circle C where AB is a diameter. And then it says find the measure of each arc on the second one. I'm going to ask that we pause the video just for maybe a couple of minutes, and you guys try those, and then restart the video and just check your answers. I'll have the answers up. So here are the answers. I added them to the paper so you can check them. Hopefully you got them right. If not, hopefully you can figure out why at some point, either now or later. I got 65 on this one, 245 degrees on the second one, and 180 on the third one. And then this U try, I got 125 degrees, then 270 degrees, then 215 degrees. So this next example is just kind of like a little word problem using the same concepts though. So here we see a circle graph. So it's kind of like a statistics application of this because we do sometimes see circle graphs like in the news and things. So it says, for how long did you brush your teeth? By the way, I don't know if you know how long you're supposed to brush your teeth, but I feel like it's 2 minutes is recommended. So it looks like in this circle graph, we have degree measures associated with each like portion of it, but we actually like don't necessarily know the percent of the people, although we could figure it out. But what it's asking for here is it says, a survey asked how many minutes they spend brushing their teeth. The circle graph shows the results. Find the indicated arc measures. So the first arc is arc ABC. So arc ABC, I will highlight that in like a purple color. So from A to B to C. So we're just doing 120 plus 82. So 120 plus 82 is 202 degrees. The next one is measure of arc ACB. So from A to C to B, oops, I meant to use a different color. From A to C to B, I'm going to highlight that in orange. So from A to C to B, it's a major arc. We just need to add all those portions together. So we're going to take 82 plus 4, sorry, I forgot where it was for a second, plus, oh no, sorry, I have the wrong number there. 82 plus 13 is 95 plus 145 degrees. You should end up getting 240 degrees for that one when you add all its portions together. The next one that I'll highlight in yellow is measure of arc BD. So from B to D, looks like it's just 82 plus 13. So 82 plus 13 is 95. And then the last one is measure of arc CBD. So from C to B to D, I'll highlight in pink. From C, that's a big arc because you gotta start at C, then go to B to D, all the way around the circle except for that 13 degrees. So the fastest way to get it would just be 360 minus 13, which is 347 degrees. Okay, so that page honestly was kind of all the same concepts. So just further like making sure that you understand the notation of what it's asking for. And the idea that the central angle creates a congruent arc in terms of its arc measure. This bottom example had a context to it. It was kind of like a story problem, but we didn't actually end up using the context at all. It was kind of just the same thing we had already been doing. So on the last page of your notes, we just have some theorems. Remember, there are no proofs in this chapter. So you don't need to worry so much about like memorizing the names of these theorems. You just need to know how to use them. And I think they're probably mostly pretty logical too. So the first one is the congruent circles theorem. It says two circles are congruent circles, meaning same size and shape, if and only if they have the same radius. So the only way to be a congruent circle is to have the same radius. If you have the same radius, it's automatically congruent. So these radii are equal to each other. It shows you that on the diagram with the mark. So therefore, the circles are congruent. Or the opposite of that, if the circles are congruent, then the radii are congruent. Then we have the congruent central angles theorem, also hopefully pretty logical. So it says in the same circle or in congruent circles, two minor arcs are congruent if and only if their corresponding central angles are congruent. So we're creating congruent arcs if their corresponding central angles are congruent. So these angles are congruent, so they create congruent arcs. Those happen to be vertical angles, so they would be congruent. And then the final one is called the similar circles theorem. So we talked about similar shapes in chapter 8. We actually had a whole unit on it. Remember, similar means, by the way, we forgot a letter in that. It's kind of bugging me. So similar is spelled wrong over here. So just know that it's actually spelled like this. Anyway, similar shapes have the same shape, different size. So all circles are similar. So it says two arcs are similar if and only if they have the same angle measure. All congruent arcs are similar, but not all similar arcs are congruent. So I think we're going to kind of be using that down here. I was going to give you an example, but I do think it comes up. So we will get more to that in a little bit. That out of the three things, this bottom part is probably the most confusing just in terms of the vocabulary. So here on this example, it says, tell whether the red arcs are congruent, explain why or why not. I realize that on your paper, you can't tell what the red arcs are. So I'm going to kind of highlight them for you so you can see them a little bit better. On my screen, though, you can see it. So we're talking about this red arc and this red arc. So they are congruent. Because of this central angles theorem, the congruent central angles theorem, the middle theorem on the top of the paper, because that says if the corresponding central angles are congruent in the same circle, then the arcs are congruent. So we're going to say yes. Oops, probably I want to use a darker color. Hold on. So here we're going to say yes. And our reasoning is the congruent central angles theorem. I'm going to use the symbol for congruent. So it's the congruent central angles theorem. That's our like explanation. The next one says, tell whether the red arcs are congruent, explain why or why not. So I'll highlight the red arcs for you. They're right here. Those are not congruent. Congruent means what it always means. It means the same size. And those are not the same size. Like if you were to get out like a tape measure or like a bendable thing and measure them, they would not be the same length. RS would be shorter than TU. So we're going to say no. To explain it, I'm going to say because the circles are not congruent. So as in the little circle and the big circle. You might be able to explain that another way and it would be fine, but that's what I'm going to say. And then this one, it says the red arcs. So just highlighting the red arcs for you. We're talking about this arc and this arc. That would be yes, because these circles are congruent. They have the same radius. So this congruent circles theorem tells me the circles are congruent. And then this congruent central angles theorem tells you that the arcs would also be congruent. So really this is kind of two theorems. Don't worry too much about the names of these theorems, honestly. You can reference them like looking at your notes. But as far as like a quiz or test goes, you would just be able to explain it in your own words. So you could say something like, yes, the circles are congruent. And the angle measures, the central angles are congruent, therefore the arcs are congruent. I'm going to use the actual names of the theorems because I have them right on this paper. But you could kind of explain it in your own words too. So it's both of these theorems. By the way, this one concept doesn't really come up on here a lot. So I'm just going to kind of use this middle example right here to talk about this circled thing up here. So I'm kind of focusing in on this part right here that I'm highlighting in yellow. In this middle example, those arcs are what we would call similar. They're both created by a 90-degree angle. So RS and TU are similar arcs, both created by the same angle measure, but they're not congruent. They're not the same length. There's a U try there. I'm just going to ask that you maybe pause the video for like 1 minute and then I'll put up the answers. I'm just going to put yes or no on these. So just take 1 minute to try those bottom three and then we'll be done with the notes after we put up the answers. So here are the answers to the bottom ones. The first one was no, the circles are not congruent. The second one was yes, both of those angles are 65 degrees. The third one was yes, because those circles are the same size. The first one has a radius of 6. The second one has a diameter of 12, which equates to a radius of 6. So that should have been your answers there. Okay, so now we have a book assignment, which I know is everyone's favorite. So the sub's going to pull up on Google Chrome. The second tab shows you which problems to do in the book. I will also write it here for your reference. Just like always, the book pages are on Google Classroom, but you don't need your phone to get Google Classroom right now because there are books in the back of the room. So for the rest of class, I want you to go grab a book and work on the homework. I'm trying to find it, sorry. I'm trying to find it for you, but I finally found it. It's on page 542 in the book. And I want you to do 4 through 28, just the even numbers, and then 31 and 36. So I will see you tomorrow. Tomorrow, you're going to show me both 10-1, the 10-1 worksheet, and the 10-2 book assignment tomorrow. Tomorrow, I know it's kind of strange to have you get a new warm-up sheet on Friday, but I'm going to have you grab a new warm-up sheet tomorrow. I'll check your 10-1 and your 10-2 work, and then we do have a lesson tomorrow on 10-3. So I will see you then. Enjoy the rest of your day.